Record. Right. So the topic of this presentation is AWS Lambdas, why and how. So this is one topic or one area that we've been working on since the past couple of years. Lambdas. Lambdas essentially, you can think of them as something that, or a function that does one thing and that one thing really, really well, right? Usually in programming, what we do is we write our code in such a way that we try to do a lot of things with that, right? I will be going through different kinds of architectures, while we develop applications, and the microservices architecture as well. But essentially, in a nutshell, a Lambda is a function that does one thing, and it does that one thing really, really well, right? That's the foundation layer or the principle behind a Lambda, right? That's a core principle philosophy, that it does only one thing and does it really well. If you are trying to combine multiple things and making a Lambda do that, that is not the pattern that should be followed, right? Eventually, you will fall into some programming related issues, or from an architectural standpoint, that is now not what Lambdas are supposed to do, right? So in terms of architectures, we've got applications which are tightly coupled. There are then those applications which are loosely coupled. Again, I'll explain these things to you. And then there are those applications which lie in the middle, right? I know a lot of people who are listening to this presentation do not come from a tech background, but let me try to break it down into simple layman terms to help you explain what this tightly coupled, loosely coupled, and in the middle essentially mean. Tightly coupled or a monolithic architecture is when you've got all the different pieces of your application as part of one big layer, right? You've got your coding part, then you've got your front end, which is now integrated with that coding part. Then you've got your databases. You're calling your databases directly from your application. And all of this is hosted inside one particular server. That is the monolithic architecture of an application. Then loosely coupled applications are those in which we break these pieces into different layers of services. Your front end is a different layer. Then you've got APIs, that is another tier. Then you've got the back end, which is another service. And they may or may not be on a server. I'll talk about the advantages in the next slide, right? And then there are applications which are in the middle, right? There are certain pieces of it which are monolithic in nature. There are certain pieces in which microservices are leveraged. Is monolithic architecture completely obsolete? No, that is not how I would put it, and that's not the correct way of even looking at it. There are certain applications which by nature would be monolithic. There are certain applications which by nature would fit into the microservices architecture. And when we are trying to combine, say suppose a legacy application, and we do not have the bandwidth, nor the expertise, nor the time to rewrite an application, but we would like to add new functionality to it. In that case, we would essentially bypass that application and leverage microservices for certain pieces, right? Now, if you compare this with the previous slide, I've just put in a representation of what the monolithic architecture is, what the microservices based architecture is. Monolith does not mean obsolete or legacy code. Don't get confused with that. nor is it, an old way of developing an application. There are still applications which fall into the perfect use case of a monolith application. But once you convert it into a microservices based architecture, these are the advantages of it, right? Agility, of course, now with microservices, what happens is, if you look at the monolithic architecture, so there is, one big team that is responsible for this complete application. And here in this case, what we do is we break it down. It could be from a business unit standpoint, or it could be from a team standpoint. That there is a team that handles the user service. There is a team that handles the post service, right? So what happens with that is that now you've broken this into smaller, more chewable pieces. Things become more agile, right? You're able to move faster. You're able to scale individual pieces. Now, for example, all of a sudden, you start receiving a lot of traffic on your APIs. So what do? You auto scale your database service to handle all that load. So you don't have to scale the whole architecture. You just need to scale that particular piece to ensure that your services are running properly. Things become easy to deploy, right? Rather than, so I've seen it so many times that there are big, old, no, okay, not old. I take that back. They're big applications. They're complicated configurations. And when we deploy it, there are certain issues that we face. Every now and then we come across such problems, and especially when we are taking over new projects. Deploying an application is a painful process as far as big, chunky, monolithic applications are concerned. Whereas in the case of microservices, because these are small, chewable pieces, they become easy to deploy, right? Tech freedom simply here means that here in case of the monolithic architecture, you needed to follow one particular stack, right? If you're developing your application on PHP, so the whole thing is supposed to be on PHP. Whereas in this case, we can leverage, each team can leverage their own technology in which they feel they have the maximum strength, in which they have the maximum capabilities, right? For example, if you are looking at, say, some parsing of documents, then you might create a microservice that parses documents based on Python. Why? Because Python is good at parsing things, right? Then if you look at certain libraries like FFmpeg, right, that's used for trimming and compression of videos. For that, you can actually use C++ based stuff. Though, we use something known as Lambda layers for it. I'll cover that separately. Now, based on the strength of each language, you can define the language for microservice. That's the beauty of it. Reusable code, yes. In a lot of cases, you will find existing templates for certain pieces. Plus, what happens is, as these problems have come up, if you have your problem set well defined, you will find the microservices based best practice architecture for it. More often than not, you will find it. And then it's easy for you to replicate and reuse those pieces of code which are already there. Resilience, right? Let's again, look at the example that we had for the scaling part, right? You can make your service more resilient. Plus, you can have error reporting, custom error reporting at each service level, which makes the layer more transparent, and it's just an ease of use in terms of microservices. But keep in mind, not every architecture will fit inside the microservices paradigm. The services that we have worked on, right? Dignitas Digital has worked on these services. EC2, that's essentially the most basic ones. The first layer is the most basic one. EC2, S3, RDS, DynamoDB, Route 53. Right. So the EC2 is for compute, S3 is for storage, RDS is Relational database service, DynamoDB is a type of database. Route 53 is, for your DNS and all that stuff. Then Lambda is again something that we have extensively worked on. Lambda is essentially a function which does one thing and one thing really well. Event Bridge, you can schedule your jobs here. You can think of it as a cron job scheduler. API gateway, so your external applications communicate with your Lambda with an API gateway. Step functions is a way for you to create workflow-based applications using Lambda. Poly, I think, is text to speech or speech to text, one of those guys. Alexa skill sets, we've created custom skill sets. Lightsail, one of our clients, we are hosting their website on Lightsail. CloudWatch, extremely helpful tool for you to debug your application as well as create alarms around your application. Right, so this is where the beauty lies, that we can create custom alarms based on these logs that are linked with your service. Everything is event driven. It can be async in nature. Then cloud formation, SageMaker, recognition, Elastic Beanstalk, auto scaling, SAM, Fargate. We've used all of them. Fargate was the one that was used for Broad Institute, the MIT and Harvard stuff. So what exactly do we get out of leveraging these services? There's no one bottleneck that you have in your application anymore, because you've distributed your services to different pieces altogether. Debugging becomes easier, and you tend to have lesser bottlenecks. If you've architected your application well, then there should ideally be no bottlenecks. Then this is something that we've observed, that we have been able to bring down the total cost of ownership, TCO, by more than 50% in majority of our clients. For those in which we've developed applications from scratch, we do not have any benchmarks, but here minimum cost saving has been 50%. Because if I take a few steps back, the advantage of cloud is that you pay as you go, right? You pay for the resources that you use. And when we are using Lambdas, we only pay for the time the Lambda function has been used. Whereas in the case of EC2, we pay for the time that server is running. In this case, in the case of Lambdas, we only pay when that function runs. And by default, the function is supposed to time out after 15 minutes. So ideally, these Lambdas are short calls. It could be some API calls connecting each other, or some small functions, or some sort of processing that is happening, that is bypassing the main system. Here we look at one of the use cases. This is the FFmpeg example that I was talking about. So here what we have done is, so FFmpeg is used for playing around with videos, right? You can compress videos, you can trim videos, you can convert them into grayscale, you can change their layout, you can auto scale them. A lot of stuff can be done. What happens is that it is an intensive IO operation, and it can be extremely blocking in nature, right? If I'm using my server for this process, my own file system for this process, then till the point the image processing is complete, I might experience a slowdown in my server. And if I'm catering to thousands and thousands of requests, then this becomes a bottleneck for me. So how do we deal with this? We bypass the system, right? Here we create async Lambdas that talk to each other. I will not go into the nitty-gritties of how to create a Lambda here. Just try to understand that you are bypassing your original system. Now you're using these assets that belong to Amazon, AWS, and you've created a complete workflow around it, broken that into multiple steps. So Lambda 1 sends the instruction to Lambda 2 that this is the video that needs to be processed. And Lambda 1 in the meantime lets the user know that your video has gone for processing. Right? We add something known as SNS, Simple Notification Service. which lets Lambda 2 know that there is something that needs to be processed. Once this thing is processed, it is added to my S3 bucket. That's my storage. And that triggers another Lambda, which, essentially calls another webhook to let the user know that your processing is complete. And this is completely async in nature. So Lambda 1 is not waiting for Lambda 2. Lambda 3 is not waiting for Lambda 2. Right? So these are completely event-driven, trigger-based applications. Right? So all these logs are being stored inside CloudWatch, as I mentioned. And they can either connect with a simple notification service or a Lambda that this is the error that you received while processing, or while sending it across to Lambda 2, or while storing it inside the bucket. And everything can be sent across via email, or it can be sent via your Slack channel. Skype does not have this webhook feature. So for this example purpose, I've used Slack. Right. Second, this is something that we are actually implementing. Not exactly this, but somewhat this is in the pipeline. Right. So we are developing a lead pre-processing filter. So we are using various tools for our sales process. And this workflow is essentially used to find out the relevant leads, put them inside, clean them, right? Find the relevant information associated with those leads, the correct email addresses and everything of the relevant personnel. And then it gets added to the CRM. The CRM in our case is HubSpot. And along with that, we are able to manage the lead status inside the system. And once this is done, a notification is sent to Slack that your leads for today are ready. You can initiate your marketing process, right? So this is the lead generation sales part. Then comes the marketing piece. The marketing piece would essentially revolve around certain campaigns, email marketing campaigns, and how we process the information based on that. That is something that is being worked on. We'll probably be giving you a demo of that sometime next week. So this is, another use case of how we are using it. Other examples, where we can use it and we are actually using it. Server management for not auto-scalable instances, right? So there are certain instances in AWS which do not follow the auto-scaling paradigm. Now, in those cases, you can create your custom Lambdas. Also, in certain cases, when we are working with business-to-business applications, these applications or these servers are only supposed to run during office times. So we can actually create Lambdas to shut these systems off during the weekend, plus during off-office hours. A very basic example. Now, this is a very low-hanging fruit. Using this, you are able to save more than 50% of the ownership of that server. I'm not talking about the total cost of ownership, because there'll be a certain cost associated with building these Lambdas. But overall, as recurring revenue, you will be reducing your AWS bill by 50%. And if you're using multiple servers and really big machines, that's a huge number that we're looking at. Right, lead management custom workflows. So for CRM, this is something that I already explained. Lead management and calendar bookings. Again, this will be part of the marketing workflow that we will probably be able to demo you next time. Any heavy duty processing. So this is something that Jay has probably been working on. So this is part of our products group that we are creating some custom crawlers, and this crawler being heavy duty processing and multiple Lambdas involved. So this is another example where you can leverage the serverless or Lambda layer. Zapier alternative for many cases. This is a very, very strong business case. So those who've used Zapier is used to connect to different applications. But it's a very good tool, but the issue with that is that it is expensive. So it is not a very scalable tool. it is going to work fine as long as you have got 200, 300, 500 calls to deal with. But if you are having multiple touch points, in that case, Zapier is going to fail, or it's going to burn a hole in your pocket. So that is another, really good business case where people who are working in Zapier or who want to convert their business model into a SaaS-based model and want to move away from Zapier, that's where these kind of functions fit in really well. Yep. So that's it from my side, guys. Hopefully next week we will be having.